Okay, this is next video in the series, so this is chapter 14. Still lecture 1, part 4 actually. Now what I want to describe to you is this thing here, Ka times Kb is equal to Kw, okay? And you might be thinking, well, wow, that's just something I need to memorize. Now what I want to do is demonstrate this to you. Let's look at an acid. Okay, so we got the acid, we got the conjugate base, and we have this proton here. And this value, well, we call it Ka, right? Ka is equal to products over reactants. Okay, and for Kb, we know that if we have a base, it can react with water to produce the conjugate acid, and it can produce hydroxide ion. And the Kb value is products over reactants, but not the water because it's liquid. So that's Ha, OH minus, A minus, okay? And what I want to do is apply the product rule, okay? So we're going to add these two equations together, and using the rules of equilibrium, we're going to multiply the Ka and the Kb. So let's add these two together, okay? What we get is and on the right, we add all those products up. Keep the states and everything carefully written. Okay, so this describes the chemistry. Now, what you'll notice is that there's Ha on both sides. There's A minus on both sides. So the simplified reaction is going to look like this. Water is in equilibrium with H plus and OH minus. Okay, so that right there is the chemistry. Okay, so if you add these two equations together, you get this ionization of water. Now, I want to switch to the mathematical analysis. Remember, if you add two reactions, the equilibrium constant for the combined chemical reaction is going to be the product. Okay, we're applying the product rule. It's going to be Ka times Kb, right? So it's going to be all that stuff that I circled times all that stuff I circled. So it's going to be H plus times A minus over Ha times Ha OH minus over A minus, okay? And mathematically, we have A minus on top and the bottom. Mathematically, we have Ha on top and the bottom. So the Keq for this is going to be equal to, after simplification, H plus times OH minus over nothing, right? Just 1. And that's basically, that's correct. If we write the K KW, remember this has a special name when we talk about the auto-ionization of water. The KW is just H plus times OH minus. So that's what we've basically proven here. If you add two equations, you multiply the two equilibrium constants. So what does that mean? KW is equal to Ka times Kb, okay? Remember, Ka is this value here, Kb is this value here. We multiplied the two and we got Kw. So this is a useful relationship, okay? If you don't have the Kb and you need the Ka, you could solve for it, okay? So let's do an example or two here. What is the Kb if Ka is equal to 1.4 times 10 to the minus 6? Okay. So I use this formula. I solve for Kb. Okay. And I plug things in. Now remember that Kw is 1.0 times 10 to the minus 14. It's a constant at, 20 degrees Celsius. So 1.0 times 10 to the minus 14 over Ka, which is given, 1.4 times 10 to the minus 6. That's going to be equal to 7.1 times 10 to the minus 9. Okay, so that's Kb. All right, let's do another one. If the Kb is 1.4 times, well, let's use a different value. I keep using 1.4 here. 2.5, 10 to the minus 5. What is Ka? Okay, so again, we use this relationship. Kb is equal to Ka times Kb. We solve for Ka. I urge you to type these into your calculator because sometimes the TI-37 series has a problem. We have 10 to the minus 14 up on top, and we have 2.5 times 10 to the minus 5 on the bottom. Okay, and here we can calculate the Ka for this substance. Now, we're not saying an acid is a base or a base is an acid, but remember, the acids and conjugate bases are flip sides of the same kind of coin. On my calculator, I get 4 times 10 to the minus 10. Okay? So let me give you your practice problem. Let's try this one. If the Ka is 6.3 times 10 to the minus 8, what is Kb? Okay, here's another practice problem. If the Kb is equal to 2.6 10 to the minus 2, what is the Ka? Okay, enter those on your worksheet, and I'll assume that you know how to do this type of problem.